Dr. Doug Rao and myself, Dr. Nikki Cooley, would like to welcome you to Lecture 3 on the topic of sustainable and equity in global food production. This lecture is part of the Bachelor of Agriculture and Technology in the subject Food Production in a Changing World. Please visit our website at www.nmit.edu for any further information on this course or other courses that we offer. This degree is offered by both NMIT and Melbourne Polytechnic. In this lecture today, we are going to review the components of the history of food production, that of the influences of global population, sustainability and equity in food production. In this lecture, we will examine, in part, 3 learning outcomes. The first learning outcome will enable you to discuss the drivers of change of contemporary food production systems, hence sustainability and ethical, which include global population dynamics. We will also investigate the issues of change and sustainability in global food production systems, including population growth. And finally, we will look at sustainability from an Australian perspective in the face of changing global food production mechanisms. In the last lecture, we considered how global population dynamics was a key driver for food production. Here we will explore this in some more detail with the aid of some resources. The first resource I would like you to review is in the form of an online talk. Please watch this talk. The topic covered in the video is of demography, which is the study of human population. Once you have watched the video, please answer the following questions. What is sensor data and why might it be useful in agriculture? What is the point this video makes about sustainability? What part of the sustainable issue relates to food production? What is the major source of the United States population growth? What does the video suggest about urbanisation? Why is urbanisation important in food production? And how will climate change impact on food, on population dynamics? We will review the answers in one of the tutorials. Now that you have watched the video on population change and global population, you will have some understanding of its inputs and outputs. The following equations summarise a simple calculation of population change. It is as you would expect. The number of births plus the number of immigrants into a country minus the number of deaths and the people leaving the country equals the change in population at any one given time. Please note that population change is slightly different to that of total population. The biggest change to populations in the 20th century are not necessarily the number of births or the number of deaths or the number of people moving in and out of countries, but it is actually how long the average person is living that skews this formula. The global population and how it relates to food production has been in the past and still is of a concerning nature. I'd like to introduce you to the Food and Agricultural Organization of the United States, or FAO for short. They produce a website where you can see the current global population changing in real time. When you get a moment, please visit this, as it's quite an experience to watch the population increasing as you're watching and reading the site. You will note, when I last looked at this page on the 7th of July this year, the population was about 7.277 billion people. The FAO spend a lot of time analysing and trying to understand population and population change. In 2009, they did some modelling and looked at some statistics. They noted that in the last century, up until 2009, that there had been rising hunger in the world. And as of 2009, they calculated that there were 1 billion chronically hungry people on the planet. I'm going to give you a moment to think about this number. It's a large number. The number can be broken down by areas. For example, there are 642 million chronically hungry people in Asia at this time. There were 265 million hungry people in the sub-Sahara Africa, with 53 million in Latin America, and about 42 million in the Near East and North Africa. Many of these regions cover developing or chronically poor countries. You will note that Australia and Europe are not on this list. The FAO have cited several factors contributing to the current rising hunger. The main one was population growth. In addition to this, they quoted that there was a sharp hike in the cost of grain prices. They even stated that this set off riots in some countries. There was also a global recession, and this boosted unemployment. The FAO also estimated that a current 105 million people were hungry due to what they called an economic crisis. So we can make the statement that there is hunger on the planet today. And if there is hunger today and population is a predominant driver in this hunger, what do we hold for the future? You saw in lecture 2 the predicted population changes for 2030 and 2050. If we look at the FAO's predictions, we can start to see some sobering forecasts on the world food production. Let us say that by 2050 the world population is 9.1 billion people. The FAO have predicted that a 70% rise in food production must occur to feed these people adequately. This will equate to a doubling in food production in the developing world, and as you will have noted from the previous slide, it is in many of these developing countries where the hunger problem occurs. The FAO also touch on an issue of estimation. That is, that they have probably underestimated the amount of rise production in food, as they have not factored in the competition of agriculture for other enterprises such as biofuels or the producing of crops for medicine or competition for resources. There are other issues as well, such as increased energy prices, the amount of fresh water reserves that are available for farming. A big influence is the loss of farmland or urbanisation. And how will carbon accounting conflict? We know, for example, that there is an increasing demand for the product beef. Beef produces large emissions of nitrous oxide, which is a very powerful gas in carbon climate. For every one molecule of nitrous oxide it is produced, it is equivalent to 300 molecules of carbon dioxide produced. A second resource that I would like you to obtain to add to your lecture notes is that of an article written on food population, agriculture and malnutrition. This article enables you to explore some of the key drivers such as world population, water, land and energy in more detail. You can review this lecture and add this article to your lecture notes. So we can conclude that the rise in global population is leading to current and future farming issues. That is, we have to produce more food to meet population dynamics. We also ideally would like to do this in a sustainable and an equitable manner. But what exactly does that mean? In the next part of the lecture, we will explore this in some detail. Sustainable agriculture can be defined as the efficient production of safe, high-quality agricultural products in a way that protects and improves the natural environment, the social and economic conditions of farmers, their employees, and the local community, and safeguards the health and welfare of all farm species. The following image is a simple way to think about sustainability. As we stated in the previous slides, the definition for sustainability was how the development impacted not only socially but environmentally, and that it must be economically sustainable. In this lecture, we will be looking at examples of Australian agricultural enterprises and how sustainability has driven agricultural food production change. So it is the conversion of the three pillars of economic development, social equity and environmental protection that defines how sustainable an industry is. So what do we mean by all of that? Well, put quite simply, if an industry is very fair from a social perspective, it is very livable from a social person perspective. That is, that it's an asset to both society and the farmer. If an industry is economically fair and viable, and if an industry is environmental, livable and viable, good for the environment, then you can state this industry is very sustainable. Another important aspect of sustainability that we're going to add in now is that it needs to fulfill the needs of both current and future generations, or it can be said to obtain generation equity. You can use this image and definition of sustainability to actually quantify or state how sustainable an agricultural industry is. As you know, there will be some industries that adhere to all of the components of sustainability, but many won't. The components of sustainability are in fact a very difficult or high bar to attain. Some industries may be quite economically viable, be reasonably fair to the social entity, but be not very environmental friendly. In this case, they would sit above the centre of the sustainability image. An industry may be very sustainable in one era, but a single change, such as a change in the market or the consumer preference, or the degradation of land, for example, may move that industry from sustainable to outside the sustainability definition. The blue arrow on the slide of this image is demonstrating that move. Conversely, an industry may currently be sat on the outside of the definition of sustainable, and with a change in either the environment, social or economics, move towards the sustainability or sustainable part of the definition. We can say that an industry is moving towards sustainability, or as the arrow shows, we can also say an industry is moving away from being sustainable. From the objective of this course, the previous definition of sustainable agriculture can be used, but please note the definitions of sustainable are complex and varied. For example, definitions can be used to drive promotions, or they can be changed depending on the end user's objectives. There are generic or general definitions that apply to sustainable agriculture. There are legal ones, such as that stated in the US. Under the US Code Title 7, Section 3103, sustainable agriculture, for example, means an integrated system of plant and animal production practices which have a site-specific application that will, over the long term, satisfy human, food and fibre needs enhance environmental quality and the natural resources base upon which the agricultural economy demands, make the most efficient use of non-renewable resources and on-farm resources, and integrate where appropriate natural biological cycles and controls. It will also sustain the economic viability of farm operations and enhance the quality of life for farmers and society as a whole. This legal definition very much matches with the definition on the previous slide. But you will note, when thinking about the detail here, what exactly is meant by environmental quality, what exactly is meant by natural resource. Sometimes these inputs are not clearly, or more to the point, easily defined. There are also industry-specific definitions, that is, an agricultural practice in one industry may be quite different to that of another. Therefore, when you are reading and describing literature in this area, always be aware of what is meant by the author by sustainable. Who is writing it? Why are they writing it? We will start with the Australian sheep industry and use this as an example to highlight how an industry can be sustainable or not. Agriculture, especially wool, established in Australia as a thriving economy with substantial workforce, service industries and large port requirements in big cities. Australian agriculture benefited from many different agricultural practices, both formal and informal land grants, overseas capital and access to relatively cheap labour through Indigenous workers. It combined the innovation and hard work which has led to the Australian which has led to Australia becoming a lead exporter of fine food and meats. About 50% of Australians' landmass is used for livestock, and therefore it can be reasonably argued that it is important environmental farming enterprise to consider for this reason. Assuming that the industry started in about the 1840s, once you hear this overview of the industry, you can ask yourself a question: was this industry sustainable in 1901? The answer is complicated, in parts yes and in other parts no. And in the next slide we will examine this in further detail. Of course, when examining this, you have to assume no future knowledge after 1901 when answering the question. So let us see how the industry was sustainable. Looking at the definitions that we are going to use in this lecture, the industry did satisfy human food and fibre needs, both in fact. And yes, the industry did sustain the economic viability of farm operations at that time. There was a balance. In part, the industry was not sustainable, as farming practices were not developed to enhance the environmental quality and the natural resources. But where stocking rates were low and a large land mass was used, you can argue that there was a minimal impact, although you do have to equate in the selective grazing by sheep and other cattle, and they may impose imbalance in some local plant communities. The industry at that time was not the most efficient use of non-renewable resources. It just simply wasn't an aspect. And on-farm resources and integrated where appropriate natural biological cycles and control. That said, there were examples at the time, due to the lack of development of technology, where such farm aids like using horses to gather the sheep were in fact by definition very sustainable. A lot of the material at the time may have been renewable because that was all that was available, but it was not a driver of the industry. And when you look at the enhancement of quality of life for farmers and society, again the answer is both yes and no. Certainly the quality of life for some farmers where they were successful was enhanced, and certainly society as a whole was enhanced with the ability to feed the population to export and add wealth to the country, and to make clothing. All of these very beneficial. However, it is well known that labour was very cheap and used a lot of indigenous labour, and therefore from this perspective one could argue that profits were not shared and there was an inequality in the labour market, and therefore no. So as you can see, the Australian sheep sustainability at this time is one of conflict. From 1901 to 2009, there has been a dramatic decline proportionally in the income from war, and people employed in agriculture has dropped from about 14% to a lower 3%. At the same time, there's been an increase of the head of cattle and the variety of profitable agricultural export industries. Most of Australia's agricultural products continue to be exported, and farmers supply about 93% of Australia's food, of which sheep farming industry is one of those. Farming methods have changed over the period from 1901 to current day practices. These methods or changes are described as resilient and inventive. They involve both the use of technology, attitude changes, and matching Australian farming conditions with what we can do best. Some of the challenges that modern day sheep farming have to undertake is the supply of fresh water for the sheep, reducing the use of fertilisers, reducing the land clearing, ensuring that overgrazing does not occur. It has to compete with increasing energy and transport costs. It has to deal with pests, both new and old, and the ever-increasing labour costs that have been associated with the change of time. So, in order to make these changes, it's looked at mechanisation largely and new technologies. It's looked at the industry more holistically, and therefore it's aimed for a more sustainable industry. So, can you now argue that lamb farming in Australia is sustainable? Well, the answer really isn't yes or no, but more that it's moving towards a more sustainable industry. For example, the Australian beef and lamb industry produce one of the lowest carbon footprints of any major meat-producing country in the world. This initiative came about as tree clearing was halted, and a higher proportion of the animals graze pasture-dominant diets. Water was looked at extensively. It takes between 103 to 540 litres of water to produce 1 kilogram of red meat. This is based on a study conducted by the University of New South Wales. Often a figure of 50,000 litres to produce a kilogram of red meat is quoted in the media. However, this figure is inappropriate measure. It arises from the virtual water figures that attribute every drop of rain that falls on a farm to the production of red meat, that does not take into account the fact that most of the water ends up in waterways, or is evaporated, or is used by trees and plants and in the pasture and not grazed by cattle. Another important step forward is that the industry, by its own acknowledgement, is committed to ongoing environmental improvements. That commitment can be seen by an investment of about 13 million in R&D each year. Some of those costs are covered by the government and some by the industry itself, with the aim and sole aim to further reduce the industry's environmental impact. If we review now, is the industry currently sustainable? The answer is it is definitely moving towards a more sustainable industry. So, let us use the theory of sustainability and the three-pronged approach, social, economic and environmental, to compare the Australian sheep industry in the 1900s compared to modern day. In summary, I would say the Australian sheep industry had tendencies towards being economic and touched a little bit on environmental viability. That was due to the stocking rates, although the removal of trees would have led this just to be on the verge of environmental. Socially, there was not much equity in the industry at the time. Modern day sheep industry, however, have made a change. They've moved more towards sustainable. You can't say they meet every requirement for sustainability, but they are certainly economically viable, and they are certainly changing production techniques to become more sustainable from the environment and from the social perspective too. Having learnt about the Australian sheep industry and that there have been changes towards sustainability, this allows me to introduce the concepts of weak and strong sustainability. In some ways, they are as they are described. Weak sustainability is intergenerational equity is sustained even if natural resources are somewhat diminished, as long as future generations are able to continue to have some forms of wealth creation and an overall ability to create wealth from natural resources. Strong sustainability is where intergenerational equity is only sustained if natural resources remain undiminished from generation to generation, and they should not inherit a degraded environment. So now we have a better understanding of sustainable issues. Let's bridge the gap between these and link them to how they change food production. In other words, how has the need for Australia to move towards sustainable lamb farming changed food production practices? Food production changes have been made in this industry by less land clearing. This has allowed the industry to think more holistically about its environmental impact and change production techniques. On-farm water management systems have needed to change. This has resulted in infrastructure changes to water delivery. Where fertilisers were added to grey sheep pastures, monitoring of fertilisers has driven an increased efficiency. Thus, this, in some parts, is driven also by economics. That is, fertilisers are expensive. The requirement to use less energy or to reduce your carbon footprint as an industry has indeed acted as a modern driver of change. Again, the cost of energy has been tied up with this change. The industry is investing a significant amount of its resources into research and development to look at strategies to be more sustainable in their farming methodologies. In all of these, it is worth noting that the above changes result in more sustainable farming practices. We are not saying the industry is sustainable or that it is not sustainable, but rather that it is moving towards sustainability. Sustainable drivers can be linked with other drivers and sometimes are hard to differentiate, like economics, markets, and changes to consumer preference. The example about energy probably sums this up the best. It is hard to differentiate whether economics is the principal driver or a requirement for the industry to be more environmentally friendly or sustainable that is driving more energy efficient uses in this industry. Another example I'm now going to look at is the Australian wheat farming and sustainability. Let's touch on a little bit of history. European farmers developed soon after British colonisation and European settlement in Australia. About 3 months after their arrival of the First Fleet, which occurred in January 1788, the livestock in the colony consisted of 7 horses, 7 cattle, 29 sheep, 74 pigs, 5 rabbits, 18 turkeys, 29 geese, 35 ducks and 209 fowls, a humble start to Australian agriculture. However, there were great differences in establishing agriculture in this country. European food was in short supply until the more regular arrival of the ships and the beginnings of trade. Europeans relied heavily upon eating native game and fruits to feed themselves in Australia. Fish, oysters, and a trade with Aboriginals in kangaroo was the main diet of those in Sydney around this time. Throughout the 1800s, colonial governments sponsored surveys and explored open up new tracts of land for different agricultural enterprises. In New South Wales, after George Evans discovered the Lachlan River in 1815, the surveyors, General Oxley, successfully surveyed and described the country by following this river, access to and down the Macquarie River. In 1816, Allan Cunningham found a way through into Queensland. Hamilton Hume, an experienced explorer, and William Hovell reached the Murray River in 1824, and then headed southwest and discovered and crossed the Ovens and the Goulburn Rivers in Victoria. Major Mitchell was appointed as the Surveyor General of New South Wales in 1828, and by 1834 Mitchell had drawn a map of the colony divided into 19 countries with a description of their boundaries. Mitchell's surveying started a land rush of people keen to settle in those areas where they could benefit from their rich soil and open plains. And this is where the start of the wheat industry really kicked off. Farmers and pasturers known as squatters, who squatted on the land without formal land grants, gradually moved inland and occupied huge areas of pasture for cropping and grazing cattle and sheep alike. The developments of the crops were very much driven by limited rainfall distribution. For example, about 30 centimetres or 12 inches of rainfall a year was needed to grow a crop. The temperate buffer between the 20 and the 12-inch rainfall lines separates the coastal areas from the semi-arid zones across Australia. This buffer is where it is known to be suitable for cropping and has become keenly known as the wheat belt. This buffer to today is used as a guide for where you can and where you shouldn't grow wheat. The modern wheat belt in the eastern states was established in pastures of the west of the Great Dividing Range, and railways established in railheads in these areas in 1870. The infrastructure was needed in order to support this industry. Victoria suppressed South Australians' wheat production in 1890s. Western Australia became a major grain producer in 1905, and then New South Wales became the premier producer in 1910, overcoming low soil fertility for cropping through the application of superphosphate and nitrogen. In the 1890s, the introduction of superphosphate and nitrogen to improve soil fertility enabled a tendency to crop and overgraze in low rainfall areas. 100 years later, this has led to the challenge of soil erosion and salinity. Contemporary management recognises that pastures grazed in low stocking rates such as beef have a much lower need for fertilisers than other crops like wheat. So in summary, this enterprise was a mix of exploration in the early days, government surveys, limited by rainfall, and industry impacted by drought and flood, along with low soil fertility. So is the Australian wheat farming sustainable in the 19th century? Well, again, it showed aspects of some sustainability. It was mostly economic, although it was very dependent on the season and climate. The industry did satisfy human food requirements. Farming practices were not developed to enhance environmental quality and natural resource. In fact, they did the exact opposite and led to a large amount of soil degradation and issues. Large inputs of fertiliser were required to combat low soil fertility. A large area of land mass was required in order for the farm to run economically. So a big no from the environmental perspective. They did not, and to this day, do not make the most efficient use of non-renewable sources and on-farm resources, and integrate, where appropriate, natural biological cycles and control. Although modern day approaches have moved some way towards this, with the CSIRO's development of reduced internode lengths one genetic change have resulted in wheat plants being much smaller. This has enabled a better change of resources across the wheat plant. That is, it needs less fertiliser, and also is less subjected to lodging, a problem of Australian wheat farming in Australia. So let us have a look at what all of this looks like on our diagram. As our image suggests, in the 1900s the industry was not very socially applicable, and certainly was not a good advocate from an environmental perspective. In 2014, with the many changes that the industry has shown, this has indeed changed, and in fact there is a more tendency to be more sustainable from an environmental perspective and a social. However, the industry still has some way to go. On the slide is a list of some of the industry production drivers that have resulted from the Australian wheat industry becoming more sustainable. These are a reduction of tillage. This is the practice where, based on European farming, the soil would be turned over annually. The problem with this is it leads to soil degradation and loss of fertilisers as they blow away in the soil. Recommendations and changes based on evidence and research have demonstrated that long-term productivities can indeed be increased. Not only that, but the industry can make claims to its increased sustainability. There is also a long-term reduction to the use of fertilisers and application technologies. GPS tractors can now deliver fertilisers where they are required, using certain sensors to detect the amount of nitrogen in the wheat plant at any one given time. This technology has taken off particularly in Queensland and New South Wales, where large areas of wheat farming are taking place. Varieties have been bred with increased water use efficiencies and thus can grow better when we have less water. Breeding has also resulted in the reduction of internodes. This has given smaller varieties, which means more of the fertiliser or resources go into the wheat production rather than holding the plant up in stem. The smaller varieties have also reduced an industry problem called lodging, where the plant used to fall over. This is an observation that is not seen in Europe, but was seen greatly here. And we have tendencies for better soil management. We can measure our soil composition now, and we can make changes. One of the good advancements is being able to control the pH of the soil. This allows the plant to increase the amount of fertilisers that it can uptake at any one given time. This is a great efficiency for the industry. An interesting industry to consider is the Australian whaling industry and how this has changed from a sustainability aspect over time. Whales were farmed for many reasons, and women corsets were produced as one of those reasons. The industry really kicked off in about the 1820s to 1830s, and during the period between the 1820s and 1930s showed examples of being very successful. It was at the time considered an example of a sustainable industry, although that may be hard to believe. There were plenty of whales and no harm to the environment at this stage. It was very sociably acceptable, as women could wear large fashionable dresses. It also enabled and was economically viable. There was, however, a great risk to life, as whaling is dangerous. But at the time, in this early period of the industry, it was considered worth the risk and worth the monetary return. Between the periods of 1930s to 2014, the modern day whaling industry has changed dramatically. The Australian whaling industry has ceased, but there still remains an international whaling industry, albeit quite small. Cheaper materials were developed from the corset's perspective, along with fashion change, and this resulted in a reduced need for whale bones to be used to furnish women's garments. This meant that society no longer had a requirement for this particular aspect of whaling. The whale industry did supply food and wax for candles at the time. This too changed. Fashions in food changed, along with other materials being developed which were more efficient than the wax for lighting candles. There were a number of changes that happened as a result of these changes. It was no longer worth the risk because the economics had become an issue. Whale meat was no longer in many countries in demand. Whale supplies also dropped considerably. A lot of whales were used and taken, and it takes quite a while for this particular mammal to restore its population. The industry has still hung on to today and supported by only a few countries, but most famously Japan. However, because the fish supplies are so low and the number of whales are also so well, the cost of production to this industry is high. That is, it costs a lot of money to obtain the whales. There is an increasing animal ethics movement which is aiming to stop whaling altogether and would like to see it banned. Therefore, we can see, if we track the history, that the whaling industry used to be sustainable and now is no longer so. The star that represents this industry on the right-hand side of the slide is no longer anywhere near the circles, and it is tending towards or away from sustainability in 2014. I wish to introduce the concept of scale and sustainability. Scale is a dimension in which an observation is made. There are two types of scale that apply to sustainability. There is a change over a distance or an area, and this is called spatial scale. And then there is a change over time, and this is the temporal scale. Within this, there are further definitions. There is broad scale, which is a great distance or a long distance, precision of the observation is less. And there is also fine scale, which is the obvious opposite to broad scale, a small distance or time, and it is again the precision of the measurement. So therefore, when considering sustainability, not only does the scale have to be specified, but most importantly, it has to be appropriate. I now wish to talk about ethics or social sustainability in agriculture. The following diagram sums up many of the components that make up equity or social sustainability indicators in agriculture. As you can see, many of these will be obvious, like economic viability, the employment opportunities of a society, the presence of leaders and innovative people, the ability to be able to participate in that community, the cooperation, the feeling of neighbours, and a sense of community belonging are all very important in social sustainability aspects. There is also a sense of how the future will be and the political representation and perhaps realisation about how sustainable communities can occur. Communities that are socially sustainable can lead to a concept of resilience. This is not something I'm going to cover here, but we will touch on later on in this subject. So, food production drivers can be aided by resilient communities. That is, if one agricultural industry is no longer economically viable in an area, the community can help to adjust and change to another agricultural industry. For example, if sheep industry is no longer viable, you may choose to change your industry to cropping. It may not be viable because international market and demand for sheep are no longer there. So this brings us to the end of this lecture, and in summary, you will have learnt about the important role of global population in both its historical, current and future context. It is without doubt the number one driver of food production change, both past, present, and almost certainly future. In this lecture we also learnt about how sustainability, and to a lesser degree ethics or social interactions, can enable food production change. At this point, after following this lecture and doing the readings, you should be able to describe the impacts of food production by both of these drivers, give examples, and present both past and present, and how they have influenced food production. You should be able to describe how sustainable agricultural industry is, and understand how the inputs of either social, economics or environmental may change this balance.